In the crystal-clear rivers and hidden lakes of New Zealand, a quiet war has been raging beneath the surface for decades. This island nation is famous for its breathtaking landscapes and unique wildlife, but it has a massive problem that most tourists never see. Invasive fish species, specifically the koi carp and the European perch, have been systematically dismantling the delicate underwater ecosystems that have existed for millions of years. These invaders act like aquatic vacuum cleaners, muddying the water, uprooting native plants, and outcompeting the local species that belong there. For years, the Department of Conservation tried everything to stop them. They used nets, they used traps, and they even tried electrofishing, but the invaders were just too fast and too resilient. Then scientists decided to try something radical. They released a highly specific biological agent into the water, a targeted solution designed to eliminate the invasive carp once and for all. It was supposed to be the ultimate surgical strike in the world of conservation. But then, something happened that nobody expected. The agent didn't stay where it was put. It began to spread through the waterways, moving with a speed and in reach that left researchers scrambling to understand the implications. What started as a local experiment in a few ponds has turned into a nationwide scientific mystery that is redefining how we think about biological control in the 21st century. To understand why New Zealand was willing to take such a massive risk, you have to realize just how much is at stake. Most of New Zealand's freshwater fish are found nowhere else on Earth. We are talking about the long-fin eel, which can live for 100 years, and the tiny shimmering whitebait species that are cultural icons. But these fish are under siege. When koi carp enter a lake, they don't just eat the food, they destroy the habitat. They are bottom feeders that stir up the sediment, turning clear blue lakes into brown, murky soups where native fish can't see to hunt and aquatic plants can't get enough sunlight to grow. It's an ecological collapse in slow motion. The situation became so desperate in regions like Waikato that the government realized traditional methods were like trying to drain the ocean with a teaspoon. They needed a game changer. The solution they turned to was a specific strain of a virus, often referred to as the carp-specific herpes virus. Now, before that sounds too alarming, you need to know the science. Biological control is a field where you find a natural enemy of a pest and use it to bring the population back into balance. This specific virus is what scientists call host-specific. In years of rigorous laboratory testing, it was shown to affect only the invasive carp. It didn't affect trout, it didn't affect eels, and it certainly didn't affect humans. The plan was simple. Release the virus in contained areas, let it do its work on the carp, and watch the water clarity return as the invaders vanished. It was hailed as a miracle of modern biotechnology. In the early stages, the results were exactly what the scientists hoped for. In the targeted ponds, the carp populations nosedived. The water started to clear up, and native plants began to poke their way through the silt for the first time in a generation. It looked like a total victory for New Zealand's biosecurity teams, but nature is rarely that predictable. Within a few seasons, reports started coming in from hundreds of kilometers away. Fishermen in remote river systems and hikers near isolated alpine lakes began noticing something strange. The carp in those areas were showing signs of the virus, even though those waters had never been part of the official release program. The targeted strike had become a runaway train. The mystery of how it spread so fast became a primary focus for New York and New Zealand researchers alike. Was it moving through the air? Unlikely. Was it being carried by birds? Possibly, but the real shocker was the role of the geography itself. New Zealand's interconnected drainage systems and frequent flooding events turned out to be the perfect highway for a biological agent. A single heavy rainstorm could connect two previously isolated ponds, allowing the virus to leapfrog across the landscape. But there was another factor that scientists hadn't fully accounted for: the human vector. People, unknowingly carrying water in their boots, their boats, or their fishing gear, were effectively acting as a global distribution network for the virus. As the virus spread, the scientific community held its breath. The big question wasn't just whether the carp would disappear, but how the ecosystem would handle such a massive and sudden change. When millions of fish vanish from a system, it creates a nutrient surge. All that organic matter has to go somewhere. In some areas, this led to massive blooms of algae, as the sudden lack of carp meant there was nobody left to stir the bottom, but also a huge amount of nutrients being released into the water column. It was a classic be careful what you wish for scenario. The water was clearer, yes, but the chemical balance was haywire. However, As the months turned into years, a new result began to emerge, one that was much more positive. The spread of the virus was acting like a giant reset button for New Zealand's rivers. In the areas where the virus had passed through, the recovery of the native species was staggering. Longfin eels, which had been struggling to find food in the murky water, were suddenly growing larger and more active. Native galaxied fish were reclaiming the shallows where they had previously been bullied out by the aggressive koi. The runaway nature of the virus was doing the work of 10,000 conservationists, reaching corners of the country that would have been impossible to treat manually. But this isn't just a story about a virus and some fish. It's a story about the unseen connectivity of our world. The way this agent spread through New Zealand's waters has become a landmark case study in applied ecology. It has taught us that we cannot view a lake or a river as an isolated bucket of water. Everything is connected. The groundwater, the raindrops, the mud on a hiker's boot, they are all part of a single, fluid system. This discovery has forced New Zealand to completely rewrite its biosecurity protocols. For the 2030s and beyond, scientists found that the virus was actually evolving as it spread. It wasn't becoming more dangerous to other species, but it was becoming better at surviving in the unique temperatures of New Zealand's southern Alps. This adaptation in the wild is something that lab tests can almost never predict. It showed that when we release a biological agent, we are essentially starting a new chapter of evolution. We aren't just using a tool, we are introducing a new player into the game of life. The spread also highlighted a haunting reality about invasive species management. We often think of invasive as something that comes from another country, but in New Zealand, the researchers realized that the way we move things around within the country is just as important. The spread of the virus followed the exact same paths that the invasive fish had used to take over the country in the first place. It was like the virus was hunting the carp down, following their own footsteps back through the mountains and valleys. One of the most fascinating discoveries during this period was the resilience surge. After the initial shock of the virus passing through, the lakes didn't just go back to normal, they became hyper-productive. With the carp gone, the bottom-dwelling invertebrates, the insects and larvae that form the base of the food chain, exploded in numbers. This created a massive feast for native birds and fish. It was like the entire ecosystem had been spring-loaded, waiting for the pressure of the invasive fish to be removed so it could bounce back with twice the energy. This has led to a major shift in scientific thinking. We used to believe that restoration was a slow, agonizing process that took decades. But the New Zealand experience shows that if you can hit the primary stressor hard enough, nature can recover with a speed that is almost biblical. The key is the biological lever. By using a self-spreading agent, the impact was magnified 1,000 times over. It's a high-risk, high-reward strategy that is now being considered for other invasive problems around the world, from cane toads in Australia to invasive vines in the American South. But there are still massive questions that keep scientists up at night. What happens when the carp are completely gone? Will the virus just vanish, or will it find a reservoir host, another species where it can hide out without causing harm? The fear of non-target effects is the ghost that haunts all biological control. So far, the New Zealand virus has stayed true to its targets, but the unforeseen spread has taught everyone a lesson in humility. We are not as in control as we think we are. We can start the process, but nature decides how it ends. The technology used to track this spread was also a major scientific breakthrough. Researchers use something called environmental DNA, or eDNA. They can take a single liter of water from a river and, by analyzing the microscopic traces of genetic material inside, they can tell you every species that has passed through that water in the last 48 hours. This allowed them to watch the virus move across the country in real time, even in places where they couldn't see any dead fish. It turned the entire country's water system into a giant, glowing map of biological interaction. This eDNA data revealed that the virus was moving much faster than the fish themselves. It was being carried downstream by the current and upstream by boaters and birds. It was an invisible wave that moved through the landscape ahead of any visible changes. This discovery has changed how we monitor for all kinds of things, from new invasive species to rare and endangered ones. We no longer have to wait to see an animal to know it's there. We just have to listen to the genetic whispers in the water. In the Waikato River, New Zealand's longest waterway, the spread was particularly dramatic. The river is a complex maze of lakes, wetlands, and power stations. The virus navigated this maze with ease. In the years following the spread, the river's health has seen a measurable improvement. The clarity index of several shallow lakes connected to the river has tripled. This isn't just a win for the fish, it's a win for the people. Clearer water means better swimming, better culturally significant sites for the Maori people, and a more robust tourism industry. But the story took a haunting turn when researchers found that the virus wasn't just killing the fish, it was changing their behavior before they succumbed. The infected carp became lethargic and stopped their destructive digging behavior days before they actually stopped moving. This meant that the clarity effect started even sooner than expected. It was an indirect benefit that nobody had put in the original models. The virus was effectively stopping the damage long before it finished its job. As we look toward the future, the New Zealand carp experiment is being used as a template for next-generation biocontrol. It has shown that targeted spread can be a viable tool, but it requires a level of monitoring that we've never had before. This project has shifted the focus from how do we kill the pest to how do we manage the aftermath. The nutrient surge, the algal blooms, and the sudden vacancy in the food chain are all things that now have to be managed as part of the healing process. One of the most moving parts of this story is the involvement of local communities. When people saw the water in their local lakes turning from brown to blue for the first time in their lives, they became the biggest supporters of the project. They started their own citizen science groups, taking water samples for eDNA testing and monitoring the return of native plants. The unintended spread of the virus actually helped spread a sense of hope across the country. It turned a cold scientific experiment into a national movement for ecological restoration. However, the international community is still divided. Some countries see New Zealand as a bold pioneer, while others see it as a biological cowboy taking unnecessary risks with the planet's genetics. The debate over the carp virus has reached the highest levels of the United Nations. But for the people on the ground in New Zealand, the results speak for themselves. The ghostly silence of the once brown lakes is now being replaced by the splashes of returning native eels and the rustle of healthy aquatic forests. The final result nobody saw coming was the cultural impact. For the Maori, New Zealand's indigenous people, the health of the water is synonymous with the health of the people. The return of the Maori, or life force, to these rivers has been a powerful spiritual event. The spread of the virus, although unintended in its scale, was seen by many as a cleansing of the land. It has forged new partnerships between Western scientists and traditional Maori knowledge holders, creating a unique dual knowledge approach to conservation that is now being studied globally. What this New Zealand saga teaches us is that the wild is never static. When we try to fix it, we are entering into a conversation, not giving a command. The virus spread because New Zealand's waters are more connected, more fluid, and more alive than we realized. It spread because the boundaries we draw on maps mean nothing to the forces of biology. And while the runaway spread was a shock to the system, it ultimately revealed a deeper truth about the potential for large-scale ecological healing. By the year 2035, the goal is for New Zealand's freshwater systems to be entirely free of invasive carp. It's an ambitious target, but the virus wave has put it within reach. The lessons learned during this uncontrolled spread are now being used to design self-limiting agents for other pests. Biotech that is designed to do its job and then deactivate once the target is gone. It is a more refined version of the New Zealand approach, a smarter way to play God with the ecosystem. The New Zealand discovery is a story of humility. It's a story about a small nation that was brave enough to try something new, smart enough to track it with cutting-edge science, and humble enough to admit when things went off script. It has shown us that even our mistakes in conservation can lead to breakthroughs if we are paying attention. The spread of that virus wasn't the end of the experiment. It was the real beginning of our understanding of how a country can truly heal its waters. As the eDNA sensors continue to monitor the rivers and the native fish continue to spawn in the clear water, we are reminded that the most profound results in science are often the ones we didn't see coming. We didn't expect the virus to travel hundreds of miles through the mountains. We didn't expect the nutrient surge to be so manageable. And we didn't expect the public to embrace a viral solution with such passion. But that is the nature of discovery. It's a journey into the unknown, where the only thing we can be sure of is that the world will surprise us. The invasive fish problem in New Zealand is far from over, but the tide has turned. The carp are on the defensive for the first time in a century, and as the runaway virus continues its quiet work in the remote corners of the islands, it serves as a reminder of the power of life to move, to adapt, and to reshape the world. The waters of New Zealand are changing, and this time it's for the better. The invaders are being pushed back by an invisible, self-spreading force that has rewritten the rules of the game. Looking at the big picture, this project is a testament to the fact that we are living in a new age of biology. We are moving from a reactive stance, trying to stop damage after it happens, to a proactive stance, where we use the tools of life itself to restore the balance. It's a complicated, messy, and sometimes scary process, but it is perhaps our only hope for saving the world's most unique habitats. The New Zealand virus is more than just a biological control agent. It is a symbol of our new relationship with the planet. As we conclude this deep dive into the waters of the South Pacific, think about the rivers in your own hometown. Think about the invisible connectivity that links your garden to the sea. The New Zealand story tells us that we have the power to fix our mistakes, but it also warns us that nature will always have the final word. The virus spread, the carp vanished, and the water cleared. It was a result that nobody saw coming, and it has changed everything. The ghost in the water is no longer the invasive carp. It is the genetic signature of a new way to save the world. The research continues, the data is still pouring in, and the lakes of New Zealand are becoming clearer every day. It's a bold new chapter in the history of science, one written in DNA and water. The runaway virus has become a runaway success, proving that sometimes, to save the wild, you have to be willing to let go of the reins and trust in the science that you've built. The result is an unstoppable wave of restoration that is reshaping a nation, one river at a time. And that is the true power of discovery. It's not just about the thing you found. It's about what that thing teaches you about everything else. The carp virus taught New Zealand that its rivers were more than just channels of water. They were the veins and arteries of a living, breathing landscape. And as long as that landscape is healthy, the country will remain one of the most beautiful and unique places on Earth. The invaders are leaving, the natives are returning, and the future of New Zealand's waters is finally looking bright. In the end, we've learned that biosecurity isn't about building walls, it's about managing flows. It's about understanding that everything we put into the environment, whether it's a chemical, a species, or a virus, will find its way to the most unexpected places. New Zealand embraced this fluidity and used it to its advantage. They took a risk that looked like a failure when it started spreading out of control, but turned out to be the most efficient conservation tool in history. So the next time you hear about scientists releasing something into the wild, remember the New Zealand carp. Remember that while the spread was a surprise, the result was a rejuvenated ecosystem. It's a reminder that science is an adventure, and like all great adventures, it takes us places we never intended to go, but exactly where we needed to be. The waters of the world are waiting for us to figure out how to take care of them, and thanks to a runaway virus in New Zealand, we are one step closer to knowing how. The rivers of Waikato and the lakes of the South Island are now monuments to this new era of ecology. They are living laboratories where the future of the wild is being written every single day. The invasive fish are fading into history, and the clear, vibrant water is the new reality. It's a result that redefined a country, and it's a discovery that will resonate in the halls of science for decades. Nature found a way to spread the cure, and in doing so, it gave us a blueprint for the 21st century. The story of the New Zealand carp virus is a masterclass in the complexity of life. It shows that our interventions can have ripples that span an entire nation. It's a story of science, culture, and survival that is still being written. And as we watch the invisible wave continue to move through the waters, we can be hopeful that the next great scientific discovery is just around the bend, waiting to surprise us all once again. The waters are clear, the fish are returning, and the experiment that went wrong has turned out to be the most right thing we've ever done for the rivers of the South.